Welcome everyone, it's the fourth episode of Tomorrow's Medicine podcast. And I know it is the finals week in many universities all around the globe, and I decided to do a topic-specific episode for medical students and every student that is planning to work in the healthcare sector in the future. Right now, you're pressured by your exams, you have heavy amount of material, you need to learn in order to pass it. And today I sat down with professional neuroscientist, expert on learning, Dr. Artyom Zinchenko. We'll talk about strategies, lifestyle changes, and underlying neuroscience of how your brain works, what role does attention play in it, and what role do emotions play in it. Please enjoy my fascinating discussion with Dr. Artyom Zinchenko.
Hi Arseny, hi everyone. Thanks a lot for the kind invitation. I'm Artyom Zinchenko. I'm currently a researcher, a cognitive neuroscientist. I work at Ludwig Maximilian University in Munich. I did my PhD at Max Planck Institute for Human Cognitive and Brain Sciences in Leipzig. During my PhD, I was working on topics of executive control and emotion, exploring how effective information influences our decision making and, processing of conflicts generally. Currently, my research is related to long-term memory, and specifically we're working with the context type of long-term memory. That is, how do we learn to associate certain items in space around us, positioning it relative to some other items in space, right? And how this context information is able to guide our attention and help us finding items faster. So that's the current background. So we use lots of different neuroimaging tools, most primarily EEG, electroencephalography, that helps us, identify the neuromarkers of attention, attentional processes. We also use eye tracker to pay attention where people, look at every moment of time during the task performance. And, sometimes we also use transcranial magnetic stimulation. Specifically, our interest was in stimulating the frontopolar cortex somewhere around here and see how these, frontal areas of the brain influence our attention, influence our long-term memory. So, that's what we do.
Yep, that's a fascinating research. And has you been a doctoral student also at the university you're in right now?
No, my PhD, the doctoral student, I was in Leipzig. It's a different city in Germany. Sorry, I didn't say that, right? It's a different city in the, in the east of Germany, I would say. And there is a big institution there that is devoted specifically to studying brain processes in humans.
All right, that sounds fascinating. Let's proceed to learning. Could you tell us what happens in our brains when we learn something?
Well, when we learn new information, something like what is known as a neuroplasticity happens, right? So our brain adapts constantly. And so our function, the function of the brain is organized in such a way that it's tuned to accumulate new information and then be able to use this information to improve our performance, later down the line, later in time. So when we learn new information, there are changes. There is upgrade or updates in the weights of neuronal connections in the brain. So if we were to kind of identify the brain area that is, the superstar of learning, that would probably be the hippocampus. We have two hippocampi in our brain, one in the left hemisphere and one in the right hemisphere. And that is the part of the brain that was shown to be active the most when we learn new information, specifically information such as factual information. The Berlin is the capital of Germany, or Arseny is a podcaster, something that that as a fact. So how did we kind of come to the conclusion that hippocampus is involved in memory? This happened back in about 50 years ago, when there was a patient HM. We didn't know his name for a long time because it was out of the ethical reasons, was not possible to share his identity. But after he passed away, we found out that his name was Henry Mollison. He was U.S.-American person from the U.S. And for a long time, he suffered from epilepsy. And epilepsy was quite drug resistant. So no matter what medical treatment he received, he kept having these relatively strong seizures. So what happened is the doctors were able to identify that the center, so the main excitation that leads to the epileptic seizures was located in the one of the hippocampi. I think it was the left hippocampi. And the idea was that, okay, you could surgically remove that part of the brain that is causing the seizure to occur, therefore, making his life easier. And the doctors thought, okay, well, why don't we remove not one hippocampi, but, part of the hippocampus, but both of them, just to be on the safe side, so that they don't have to kind of operate him again later on. And what turned out is that, the seizures disappeared. That was a good sign. And HM could live a normal life afterwards in terms of the seizures. But it was apparently became really quickly obvious that there were some major changes in his personality, because what happened is that he was not able to form any more new memories, right? So he would talk to a doctor who would, collect his anamnesis or, learn something about him. And then the doctor would go get a coffee. And by the time the doctor is back, HM had no recollection of ever meeting that person again, right? So, there were several researchers that basically made a career and dedicated their whole life basically to studying this specific patient and studying what kind of processes are affected by removing the hippocampus, right? So, going back to your question, what happens in the brain? So we have a hippocampus that is known to be specific for long-term memory, that is known to be specific for acquiring new information. So what hippocampus is doing is it helps to strengthen the connections in the neocortex, in the outer layer of the brain. So if we're learning some audio information, that would be the auditory cortex. If we learn some visual information, that would be the visual cortex. But the idea is that there is a connection with the hippocampus that is kind of moderates the whole process of learning, the whole process of setting weights. Well, one maybe thing to say is that hippocampus is specific for, a type of memory that we know as explicit type of memory. Yeah, that is a memory that we can consciously recall. This includes autobiographical memories about events happened to you, or some facts, some scientific facts, or like be it in medicine, learning about the brain areas and so on. However, what was also quite obvious in the HM patient, this person was still able to learn some procedural memories, right? So, for instance, this person could learn how to operate a specific machine or a specific tool. And for instance, he would be trained to perform a certain motor task for several days in advance. And the day after, he would have no recollection whatsoever ever training this task. However, his skill would be obvious. He would be really skilled in doing this task without knowing that he learned it, right? So what we know is that hippocampus is not responsible for, motor learning, learning that is more skills-like riding a bike, for instance. Yeah. So what happens is that what this tells us or shows us that brain consists of different areas, different clusters that interact with each other to form a coherent percept, form a coherent memory experience. However, exactly, there is no one center that is responsible for the whole learning process, and rather we have different areas that are involved in different types of memories.
Okay, and speaking about memory types, what can you say about long-term memory and short-term memory? What are the differences, and why should we know about the differences?
Right, that's a very good question, right? So it's kind of naturally leads us to these types of memory systems. Right. So basically, if we think about the daily tasks that we have to perform, there are some tasks that we actually need to remember something, let's say cooking, right? So when you have to cook something, you need to have a long-term memory about the whole sort of process of cooking. You need to know what kind of, food you need to prepare in advance, what's the kind of sequence of events you need to perform, to cook a certain dish. And that type of memory would be the long-term memory. However, there is also such memory type as a short-term memory, or also called sometimes called working memory. And this is a memory that persists for several minutes. Yeah, it could be up to maybe 10 minutes. And this is the memory. So like if you speak about working memory in science, that would be lasting for seconds, probably. But like speaking layman's language, so to say, we could say for several minutes. This is the memory that we need to store information short term, right? So, for instance, if somebody gives you a phone number and you have to remember it until you write it down on a piece of paper, you basically have to maintain it or rehearse it, repeat these numbers again and again and again until you write it down. So this short period of time when you kind of store something that you need, that is to perform the task, is called the working memory. And the idea is that information, it's easier for information to enter our short-term memory or working memory. Just because we need to operate something briefly. However, for us to learn something long-term, we need to make sure that this information is important. The information should be stored longer, right? So because we have a lot of information coming our senses every day, and if we were to remember everything, it wouldn't be, we wouldn't have a good life, right? So there's even a disorder where, participants or patients cannot forget any event in their lives, and that's not a good situation, right? It interferes with your ongoing task performance. So what happens? We forget things rather quickly, and to not overload our senses, we have the working memory, and once we rehearse information, we keep bringing this information up in the working memory. Over time, there is a possibility that it will reach the long-term state, and we will remember things long-term. And maybe here, I'm not sure how familiar are you with the Ebbinghaus curve, or how do you think your listeners will be familiar? I could speak of that.
I think you should describe what is it for the listeners, and broader concept for everyone to understand. Yeah.
Yeah. So basically, when you speak about memory, I think it's very important to mention Hermann Ebbinghaus, one of the most famous German psychologists back in the time. So what Hermann was doing, he was studying memory processes. And his idea was to try to identify for how long can we store information in our memory that is meaningless. Right. So what he came up with, he developed many dozens or hundreds of triplets of combinations of letters that would have completely no meaning. TAT, I don't know, whatever like combination of letters, vowels and consonants you can imagine. And he was trying to memorize certain items for a specific amount of time. And afterwards, from the end of learning, he was testing himself, trying to remember, like to check how much information he could still remember 5 minutes later, 20 minutes later, half an hour later, 1 hour later, and up until 24 hours afterwards. And what he was able to show, there is kind of exponential decay of memory. That is, we keep losing information gradually over time, and to such a degree that, we lose about 60% of meaningless information 1 hour after the learning session. Yeah. So if you were to just simply perceive something that doesn't make sense, you would lose this 60 minutes later. Yeah. Luckily, when you attend a class or you learn something, it's not completely meaningless, right? So you're engaged with reading. Maybe there is some sort of emotional component, and you try to link new information to what you know already, but still, even if for the information that we tend to learn for class, let's say, there is naturally a decay of memory loss, basically. And what we ideally should do is basically we need to bring this information up, we need to rehearse, we need to learn. And these learning sessions, what they do basically, they bump up, they help us kind of bring this forgetting curve up. Which happens through kind of operating with this information in your working memory while you're studying, and those kind of signaling the system that whatever we're trying to learn is important. It has to be stored long term, because we'll need it again and again. For a test, for rehearsal, for your practice, real life like work experience. So that's how the memory functions. In its basics.
Okay, and you're saying for something to become a long-term memory, we should assign a value, some importance to it. And when you were talking about it, immediately two words sparked in my mind. First is focus, and second one is attention. Can you say, like, what importance does attention possess, and is attention necessary to form this long-term memory?
That's actually a very good question. And to speak about attention, maybe one should kind of speak about the theory of attention, right? Sort of what model or theory of memory, what models of memory do we have? And in all sort of going back to the simplest models of memory and all the way to the modern ones, we have sort of several stages of processing how information enters our brain. So the first, the most sort of basic stage is the sensory register, right? So we have lots of sensors. We have the tactile stimulation, we have visual stimulation, we have auditory stimulation, right? We know where are we in space. And all that information is basically bombards our sensors. So we get lots of information coming into our senses every second or millisecond of time. However, not all of this information is perceived. So oftentimes you would be maybe sitting in an uncomfortable position, but you're so engaged with the conversation, you would not even notice it, right? So, or there are many cases when you do not realize that something is, touching you, for instance. Right. And so here, in order for us to be able to understand that something is important, that something is out there that demands our attention, it would be the attention, right? So we need to pay attention to something for the sensory register to enter our conscious experience, something that we can work with, something that we could memorize. So this being said, attention plays one of the major roles in memory processes, right? Because without attention, information that is necessary for us would not even be able to enter, it would not even be able to enter our working memory, first of all, and would not be able to then be processed further. When we speak about attention, maybe one important task or important point to mention in the context of memory and learning would be multitasking, right? So, for instance, if you're learning something and listening to music, if you're learning something in a noisy environment that kind of demands your attention or distracts your attention, if you have your phone somewhere nearby that kind of delivers messages all the time and distracts you from learning, all that, of course, results in detrimental learning experience. So you're basically learning worse while you're distracted. Yeah, showing that attention is super necessary for learning. Yeah, for learning acquisition.
And I believe also this agitated state, when we're over emotional about something, can also negatively affect our learning experience. I'm talking from my perspective and my experience. Can you clarify, is that true? Do emotions affect the learning curve?
Definitely, emotions do affect our memory, and we can look at it from different perspective. From the neurobiological perspective, right? So we have amygdala, the part of the brain that is really responsive to emotional information. And amygdala is located very nearby the medial temporal cortex. That's where the hippocampi are located, right? So, and there is a lot of neuronal connection between these two areas. Yeah. So for instance, if you were to experience something, some strong emotional event. In research, that would oftentimes be some disaster, let's say 9/11 in the United States, right? And you could maybe ask the people who experience this event, or like first time heard about the terror attack on the news. You could ask these people 10 years later about where they were at the time when they found out about the attack, or what they wore, what they were doing that morning, or who were around them. And it turned out that people were quite precise at identifying that moment, right, in time. However, if you were to ask them something, the same level of precision about a different event that happened the day after or the day before, let's say, 9/10, what they did, what they wore, who were around, they would not be able to tell you as much detail and information, right? So basically, when you have an emotional event that happens, it colors our memories, it makes our memories stick better, just because there is this importance attached to it. So yeah, emotions do play a big role. So on the other hand, emotions can also distract our attention. So there is this sort of body of research that shows that, for instance, positive emotions can broaden our scope of attention, and those makes us less precise, less concentrated, less focused, right? While negative emotions, to a certain degree, can reduce the focus of attention and can kind of help us study better, basically. And so the advice here would be to maybe not to be overexcited about something. To when you prepare yourself for learning sessions, maybe do not talk to your friends, to best friends, just not to be overly excited about something. But also being sad, of course, negatively influences your learning processes or ability to retrieve information from long-term memory. And when we speak about negative emotions, kind of naturally leading from here could be anxiety, right? So, for instance, you could imagine when you perform a test that is very important for you, and you're overly anxious, you are not certain about your performance. There is physically it is physically more difficult to retrieve information from your long-term memory. So even if you studied well and you prepared well for the information, for the test, right? Just being in the negative mood or in the anxious state could result in worse test performance. And that's important. However, I should say there was a big study a few years ago here in Germany where they invited a big group of students who were preparing for their medical entrance exam. I think it was medical entrance exam, just not to misinform you. But there was a big test that they were preparing for. And to prepare for the test, these students had access to a specific lab with computers. And these computers had information from last year's test questions. So the students were able to come and study there on those computers only and have access to the tests, take different tests, a mock test, and see how they do. So what participants did not know in advance, like they were only debriefed afterwards, that all their sort of activity on those computers was recorded. So there's also this meta-knowledge about, how many tests they've taken, how many hours they spent learning, so that researchers could have some objective information about how much, effort they put into learning. And, during the test, when the time came, the researchers measured participants' anxiety level and their final test score, and they also had this meta information about their learning activities. So what they showed is that indeed, so anxiety had a negative influence, or was negatively associated with the test performance. So the more anxious you are, so on the x-axis, the worse is your test performance, the worse is your grade, and that was a significant relationship. However, this relationship was moderated by the level of preparation you had. So the more time you spend learning, the more mock tests you've taken, the more effort you put into learning, the less influence of anxiety or these negative emotions on your task performance, on your ability to kind of extract information you've learned and perform well on the test. So to come back to your question, right? Emotions play an important role in your learning experience by manipulating your focus of attention, manipulating how you can extract information from your long-term memory. But they do not play the major factor, I would say. And the major factor would be the way you learn, the strategies you use for learning, and
I absolutely appreciate your detailed overview of the topics we talked about so far. So first of all, what happens in the brain. Then we talked about attention, emotions, long and short-term memory. Now let's proceed to the main topic of this video and talk about medical students in particular, in general, students who are overwhelmed by the amount of information they need to memorize, have upcoming exams and tests. And so can you, first of all, tell us about what is a cognitive load? What happens when you're so stressed out, when you have many deadlines coming to you and you need to study a huge amount as a huge amount of information, as usually medical students do.
Right. I guess medical students are a good example of, of a case where you really have to learn a lot in a short period of time. And, but I guess anyone who's listening out there, not only medical students, but I guess any sort of area where you have to learn a lot, different complex information, that would probably be relevant for them. So when we speak about a cognitive load, we go back to potentially working memory discussion, right? So in the working memory literature, we know that there is sort of a limited amount of information that we can store in working memory. So it's not infinite. So that we have a certain capacity of working memory that we can operate with information. Usually, researchers say that we can take sort of the whole sort of information around us that we're trying to learn and operate with, and we can group them together. So we can cluster, or the term we use in literature is called chunks. So we can chunk information, and then there is a sort of specific amount of chunks. It is believed that we can operate with 4 ± 2 chunks of information. Right. So, depending on your capacity of your working memory, you can operate with up to, let's say, 6 chunks of information. So if we're dealing with something really complex, so if you have to learn a lot in a short period of time, you have different classes, the whole day, and then you have to do your homework in the evening. Your working memory gets overloaded. So you cannot operate with too much information. And so that's what we call the mental load, cognitive load. That is when the amount of information or complexity that you need to operate with exceeds the capacity of your brain, exceeds these 4 ± 2 chunks, let's say. And so the strategy here would be probably to be able to kind of structure your learning material in such a way that you chunk it into smaller pieces, so that you don't have to process the whole thing at one time, right? So you kind of break it down into smaller, manageable pieces, and you study a piece by piece, basically, right? That would be the external cognitive load. There could also be internal cognitive load. That's something going back to our discussion on test anxiety, right? Being overwhelmed by, the importance of the event, something that makes you worry more, be anxious more, and that increases the internal pressure to perform well, or into like fears, and that would be a more sort of internal cognitive load. So the strategy would be to try to manage your internal cognitive load by, calming yourself down, maybe learning some breathing techniques. Meditation helps. Research shows that that's quite a helpful skill to have to be able to calm yourself down. And external cognitive load could be, or should be, managed by strategically having a bigger overview first of what you have to learn, what awaits you, and then breaking it down into smaller pieces that you can kind of process more effectively. And having to process a lot of information, of course, increases the level of anxiety, internally. So just kind of seeing smaller pieces ahead of you, kind of perceiving it as being more manageable, increases or decreases the internal cognitive load as well. Yeah.
So in your opinion, what are the best strategies for learning? Could you provide hands-on practical examples? Maybe how should I or the other students schedule my time? How should I sit down? Where? At what time? Anything that is relevant to this topic.
Right. So that's a very good question as well. So, like in your question, you touched upon several important points, right? So one important factor is basically learning itself, right? So what's the best strategy for learning? From the neurobiological perspective, what makes information stick better, right? Is there something that helps you, let's say, read or listen to a lecture and then learn better?
Exactly.
The second thing is more environmental. If there are some external factors like, that can help you stick to your learning process for a longer time, let's say where you see it, at what time of the day, and so on. So maybe let's start first with the learning strategies. There are quite a few, right? So, and you could write a book about, learning strategies and how to, learn better. I could maybe come up with a couple of sort of strategies I personally like the most, and I feel these are the core strategies that upon which everything else, like all learning sort of protocols that we have nowadays, are built around.
Yeah, please.
So, so one of the first ones would be. I would speak about spacing. I would speak about contextual interference, and I would speak about self-testing. Yeah. So these are the three strategies that have something in common. And what they do basically, they evoke or they bring up a certain degree of desired difficulty. Yeah. There is a famous memory researcher. Robert Bjorns, right, who introduced this term of desired difficulty. Yeah, that's something that is in common with these strategies. Among these strategies. The first one is spaced learning, right? So the idea here is that we are not trying to learn a lot of information in a short period of time, which would be something known as cramming, right? So for instance, if you didn't study for a long time and you have an exam tomorrow, you have to kind of spend 12 hours a day today to cover the material you studied for the whole semester and then prepare yourself for the test. So what happens in this time, if we go back to the Ebbinghaus forgetting curve, we're trying to keep this curve as much up as possible for a short period of time. So all we need to do, we need to kind of try to fit our brain, fit our memory with a lot of information that we have to kind of memorize for the test, and then come to the test and pass it. Yeah, and that works. Yeah, so usually, if it didn't work, probably we wouldn't have stuck to it. But it's a working sort of method to pass a test, but a really poor method if you would like to learn something long term. If you would like to remember something that you will later on need during your practice, during your career, let's say. So, in contrast to cramming, there is this space learning approach. And the space learning approach suggests that we study for shorter amounts of time, but consistently, so for many, many days. Yeah. So to give you an example, there was this study by Röhrer and colleagues, kind of a known person in our area in long-term memory. And what they did basically, they worked with high school students. Yeah. So what they did, they had two groups of students who learned to perform certain math operations. And what they did basically, they had 2 weeks of learning, and then after that, so like two learning sessions that had 1 week apart, and afterwards they had a test to see whether the students were able to learn this information. So the group one, the kind of the experimental group, they had during the first meeting they had 5 learning problems to perform, they kind of see how to solve the mathematical problems. And they had 1 week apart the second training session where they had 5 more problems that they trained to learn. The control group also had 2 meetings, 2 sessions. However, during the first session, they had a filler task. So there was actually nothing related to math, but they were still kind of in the group, meeting the instructor, doing something that is not math related. And then 1 week later, they had session 2 where they performed 10 problems. Yeah. So if we look at the experimental group and the control group, on average, like eventually, both groups did 10 mathematical problems. The only difference is that one group did it with like 5 problems during each session with 1 week in between. The other group had 10 at once. So, and then there were 2 tests. One test was immediately after the end of learning, and the second test 1 week later. And what happened is that if participants were to perform the test immediately, there was no statistically significant difference between the groups. Yeah. If anything, numerically, the control group performed quite slightly better. Yeah. Just because they had 10 learning sessions immediately before the test. So it was really much more fresh in their memory. However, if you look at the same groups of people performing 1 week later, the experimental group that had spaced approach performed much better. So they had about 80% retention of information, while the control group dropped down to 60%, around 60%. So that's kind of shows experimentally how the cramming versus spaced repetition works. Yeah. Maybe if you're interested, a different example would be I think it's Bradley and Langman back in 1970s. So more hands-on example. So these researchers were working with post officers, like post office workers. And back in the time, I think it was in the UK, they were moving from the manually writing or typing the addresses and, when sending the letters out to a typing machine. Yeah, so the colleagues, the post office workers had to learn how to type using a typing machine. And what these researchers did, something similar to Röhre and colleagues I was speaking about, so they had 4 groups of workers. They were really like, regular post office workers. And these post office workers had no prior experience about, typing. They were equally bad, so to say, in this task before the onset of the study. And what they did, basically, they split the workers into 4 groups. And all 4 groups were aimed to have 60 hours of learning, 60 hours of training. However, how these sort of 60 hours were split or allocated was different. And maybe I'll speak about the most like sparse and the most dense groups, like group 1 and group 4. Group 1 actually had 60 study sessions. They were meeting every day for 1 hour, learning to type. The group 4 actually had 2 sessions per day, and each session lasted for 2 hours, right? So they basically had dramatically reduced a number of days they spent learning, but eventually both of the groups had 60 hours of learning. Yeah. And, well, as you can imagine from, primed by our discussion so far, the first group performed, several times better. Yeah. And performance was, of course, measured by the number of words you could type per minute. Yeah. So, and of course, the first group performed much, much better. And the logic here is that the first group had a lot more time for consolidation. Yeah? And that's an important key term in memory, that you need to let your brain consolidate the information you've learned, the information you've recorded, so to say, in your sensory registers. So the first group had 60 days and 60 nights of sleep when the memory consolidation occurs, right? And so the weights, the neuronal connections in the brain have much more time to adjust the weights, to strengthen the weights, to strengthen the information that we learn. Yeah, so the first approach would be to space out your learning material, not to cram. Yeah. Oftentimes it's quite difficult to do, especially in medical students, for instance, who cannot plan their own learning sort of protocols, right? If you have classes every day, so you kind of have to keep up with learning information, the new information. What I would usually do, like in our classes, when I'm teaching, the students in our classes usually have a syllabus, and they usually have they know what will come in the next 4 weeks, in the next 8 weeks or 12 weeks, right? So that they are able to kind of, in advance, know what kind of material will be covered, what kind of book chapters will be covered, so they can kind of plan in advance their study sessions in such a way that they would study every day, disciplined, even if it's a short amount of information they need to learn at every study sessions, but it has to happen consistently for the consolidation to happen, right? So that would be the spacing. We also have self-tests, self-testing as a learning material. And here, maybe I would like to start with, empirical evidence, or like what it means, right? With an experiment. And then I think it will illustrate the point. So there was this work performed by colleagues some years ago, where they had 2 groups of students who listened, or who had a chance to read a chapter about either sea oysters, I think, or a sun. So there was some scientific text about, sun activity, or some, animals, some creatures, what they eat, where they live, like how they mate, whatever. So about 30 facts that were incorporated in this paragraph. And the first group of students was able to read this text for 5 minutes. And then they were given 5 more minutes to read, and 5 more minutes to read, and 5 more minutes to read. So there was 20 minutes of reading. The group 2, that's the most interesting for us, experimental group, was able to read the text only once. the only one 5-minute reading opportunity. And afterwards, there were, in the remaining 15 minutes, these students were asked to try to answer different questions about the text they've read. Yeah, they read about the sun temperature. So they're asking, so can you remember what was the sun temperature in that text? Or can you remember what was the distance between the sun and the earth, for instance, right? And many, many other facts, or some facts about animals. Importantly, the students were not given the answers. So they didn't know was their answer correct or not. Yeah, and so eventually participants were given the test, so they had to answer questions concerning, like regarding the text they've just read, and so the group that was only testing themselves performed significantly better eventually relative to those students who were able to read the material again and again and again for 20 minutes. Yeah? So there are two important factors here. One is ability to learn, to recall information, right? So every time you need to recall something, you need to kind of reach out to your long-term memory and you need to extract information from there, right? You need to kind of memorize it. And the more you learn to memorize information, the better you are at actually extracting it. So when the test comes and you have to kind of answer the question, you're better able to extract this information from long-term memory if you're practicing it. Yeah? Second thing is our brain works in such a way that we look for unanswered questions, right? So if you, for instance, provide students with the questions at the beginning of the lecture, they're more likely to learn what you're going to teach them relative to when they are not aware of these questions, right? So if you question yourself, if you're testing yourself, you're more likely to search for these answers and remember information better. This is one thing. On the other hand, a simple rereading gives you a comfort of knowing, right? So you read information, it's right in front of your eyes. And just because it's right in front of your eyes, you perceive cognitively as if you know this information. You're not trying to learn it just because your mind or your brain thinks, okay, it's right there, you know the distance, or you know the temperature, or you know like what these creatures eat, and you don't have to memorize it. Yeah, it gives you the false comfort of knowledge. Well, when in fact you do not really memorize it. It's too easy. Yeah, going back to desired difficulty.
Yeah. So this is kind of a psychological trick when we trick ourselves into thinking that we possess this knowledge. However, in reality, it's just because we're acquainted so many times with information.
That's exactly the case. That's exactly the case. So that's why the group that tests themselves are, on average, performed better relative to the group that actually had a chance to read information for longer, right? Just tricking themselves. Yeah, in a bad way. Well, the final the third tool or the third approach to learning I was planning to tell you about was the contextual interference. Yeah. So contextual interference refers to a strategy when you're trying to learn different types of tasks. You alternate the task you're trying to learn, right? So the biggest study that I like very much here comes again from Rüdiger and colleagues. So what they did, they had elementary or like middle school students learning math for 88 days. So there was a long training procedure. And if I had a chance to show you on the paper, basically they had a learning protocol where per learning session, your majority of your tasks, the math tasks that you're learning or the math problems you're trying to solve were either belonging to the same category. Let's say solving for X, or learning how to find angles in triangles, or learning how to find a square of certain geometrical figure, right? The majority of tasks belong to a certain category. And the second group had interleaved or contextually interfering themselves by solving for X in 30% of the time, and 30% of the time doing some geometry task, and 30% of the time doing something else, right? So learning how to plot on XY coordinates and so on. So in the end, both groups for 88 days learned exactly the same amount of information. Yeah, the same tasks, the same teachers, everything was identical, except for they were either kind of stacking what they've been learning, or they were kind of mixing this information. Yeah, but over 88% of the 88 days, the same amount of information was learned in both groups. And these groups were then tested again, either immediately or like one day after the end of the learning session of 88 days, or 1 week later. Yeah, and again, so in this time, the group that had the whole sort of learning material intermixed, they performed better immediately the day after the learning and 1 week later. So they were able to store this knowledge for longer, and they were able to immediately use whatever they've learned the day after the end of the learning sessions. Which, again, kind of here when we employ the contextual interference, there are multiple sort of events that are happening. So where we need to constantly change the task, we need to constantly change what we're doing. That is, we need to, again, kind of reach into our long-term memory and remember, okay, well, how do we solve for X? How do we find angles? How do we sort of plot geometrical shapes and so on, right? So basically we are training to, use our long-term memory for better, for longer. And right, so that kind of creates the desired difficulty. Yeah, it's more difficult, it's more challenging. Internal cognitive control or internal cognitive load probably raises just because it's less easy, so to say, to do so. But this shows that you can basically learn the same amount of information, but in a more efficient way that can help you store this knowledge long term better.
Efficient, you mean time efficient, or efficient through the perspective of mental perseverance put into learning?
Thanks a lot. That's a good. When I say efficient, I mean in terms of the final outcome, that you can memorize this information for longer and you can perform you write your tests better.
Okay.
Basically, that's although you spend exactly the same amount of time and the same learning material was sort of studied, but just the way you force yourself to learn, just to kind of juggling these different topics during the learning session, kind of making it a bit more difficult in that time, kind of pays off long term.
So 3 strategies: spacing, self-testing, and contextual interference.
That's true. Mm-hmm.
And could you provide a couple or maybe a few more lifestyle changes that we can employ to empower our learning capabilities?
Yeah, so that's a very good point. So basically, if I were to offer several lifestyle changes, I would say that, and it's probably challenging, I would say that one should get a bit more disciplined about learning, right? So oftentimes I sometimes, or I would say see in my students that there is no sort of plan in how you learn. You just learn from lesson to lesson, and then you kind of try to study in the last week before the exam or before you have to turn in the written report, and then you get a lot of questions from students, clarifying things, but nothing before that last week. So to be able to use these strategies I spoke about today, one should be disciplined, right? And one needs to kind of plan in advance, and that's planning ability is a task of its own, something that one needs to learn and change and kind of proactively manipulate in their lives. So that would be one. The second one, probably, I kind of spoke about this shortly, right? But we could dedicate a whole episode to this, meaning sleep, right? So you need to be able to acquire your, 7 hours of sleep at minimum per day for efficient, strong consolidation process, the memory transfer from, whatever you've learned that day to maybe to long term. Therefore, right, sleep would be probably the second, lifestyle change that you would need to implement. Yeah, if it means that you watch fewer, serial episodes online, or Netflix will suffer, or some other, meetings with friends sometimes. But sleep is very important, especially during your learning sessions, right, while you're studying. So maybe these two I would prioritize the most.
Mm-hmm. Great. So my final question for you is there some exciting research happening in neuroscience, maybe neuroscience related to learning, that you are truly excited about and you want to tell the world, like, look, this is the future, and that is happening right now?
Well, I mean, there's a lot of research going on in my area in context learning, right? Context attention, and not sure if how interesting that would be for to listeners, but so a big area of research going on right now is trying to understand if we are able to proactively suppress some distracting information, right? So, for instance, if you're reading a book and there is something salient somewhere in the background, are you able to concentrate on your reading, let's say, and ignore this information? Are you actively suppressing this information, or are you trying to basically kind of upregulate or make salient the text you're reading more? So there is a lot of research going on in this area. So we're trying to use the neural correlates of attention in the brain to, using EEG, for instance, to understand this process. And I would say it's exciting because it's still a question mark. So we don't really know what's going on. And there are different hypotheses and different attempts to explain certain brain correlates as favoring the suppression effect or favoring the no suppression effect, basically. Maybe we meet sometimes a year from now and I could tell you more, but that's something that excites me right now. And it excites me in part because we don't really know yet.
Mm-hmm. Great. So Artyom, thank you very much for participating in this episode. I really appreciate that you outlined, first of all, the basics, then we proceeded to strategies and certain lifestyle changes. I hope everyone will find this information crucial for their current endeavors. And yes, thank you.
Thanks a lot for the invitation.
Everyone, subscribe to Tomorrow's Medicine podcast, become a member on my Patreon page, and do not forget to share this video with your friends. Bye-bye, everyone.